This is number 18 in section 8.1. And here we want to determine whether these vectors are linearly independent. We have two vectors. And so we're going to create a Wronskian with where each vector is the column of it. First, I'm going to go ahead and write this x2. S1 vector has two terms here, so I'll write it as 1. And so I have 2e to the t plus 8t e to the t. And then I have 6e to the t minus 8t e to the t. And that's really what that vector represents. That's x2. So the Wronskian of x1 and x2. And by the way, you'll see me write these kind of arrows on top of vectors. It's just a symbol that identifies what I am, that x1 is a vector in this case, and that x2 is a vector in this case, just by putting this little arrow on top. It means bold, since we can't really write bold on handwriting. Usually I write that, so that's what that means. Okay, so the Wronskian is then the determinant of, first I'll use x1, which is e to the t minus e to the t, that's the first column, and then in the second column I'll put x2, and that's 2e to the t plus 8t e to the t, and then 6e to the t minus 8t e to the t. We take the determinant here, and we get e to the t times this term here, so we have e to the t times 6e to the t minus 8t e to the t minus 2e to the t plus 8t e to the t times negative e to the t. And that gives us 6e to the 2t minus 8t e to the 2t plus 2e to the 2t plus 8t e to the 2t. We can combine like terms here. These two will cancel out, and we have 8 e to the 2t. That's the Wronskian. Now, if I want to know when these vectors are linearly independent, well, that it has to be for all those values of t so that this isn't 0. So the point though is that e to the 2t, or e to the t in general, is never 0. So this is never 0, and that's true for all real numbers t. This right here is never 0. And so then I've verified then it is really true that on minus infinity to infinity, meaning for all values of t, these vectors are linearly independent, because the Wronskian is not 0 anywhere there. So the answer here is yes. x1 and x2 are linearly independent on the interval minus infinity to infinity.